Unit 5, Relations Review, Linear Relations, number 1. The water tank has a starting volume of 200 liters. The tank is being filled with water at a rate of 50 liters per minute. The total capacity of the tank is 1,000 liters. Create a table of values for 0, 1, 2, 3, and 4 minutes. Use V for volume and T for time. So this is in minutes and this is in liters. So we want 0, 1, 2, 3, 4 minutes. What is the corresponding volume? So at time 0, we have a clue here that says the starting volume is 200 liters. So that one right away is easy enough. How many liters are being added every minute? So we said the fill rate is 50 liters per minute. In 1 minute, we are filling 50 liters. So every minute we're filling 50 liters. So 200 plus 50 is 250. In another minute, we're filling another 50 liters. So that's 300, 350, and so on. So you can see the linear pattern developing already. Draw a graph that represents the data. So on the y-axis or the v-axis, we have volume V. And we have time T in minutes and volume V in units of liters. Okay. And this is filling a tank. Time 0, let's set up our graph here. That's 1, 2, 3, 4 minutes. That's 100, 200, 300, 400, and 500 liters. Okay. At time 0, we are at 200 liters. So that's your starting volume. Time 1 minute, we are at 250 liters. Time 2, we're at 300 liters. Time 3, we're at 350. Time 4, we're at 400 liters. List the data as ordered pairs. 0, 200, 1, 250, 2, 300, 3, 350, and 4, 400. Okay. Determine the following for this situation. What are the output values? Those are all your volumes. So 200, 250, 300, 350, and 400. Your input values are all your time T, minutes. 0, 1, 2, 3, and 4. Independent variable is time T. Don't forget that variable, T. Dependent variable is volume V. Is it continuous or discrete? I'm going to say continuous. Does it make sense to have independent in between values? You can have partial minutes, so like half a minute, 2.2 minutes, so those make sense. Volume as well, you can have 221 liters, 234 liters, and so on. You can have a lot of sensible in-between values. Connect the dots, why or why not? It is a continuous function, so yes, we do connect the dots. So let us connect the dots, and that is our linear function right there. Yes, because it is continuous. Next part. Choose the equation that matches the graph. I'm going to say it's this one because 50T is your amount that is being added to the tank every minute. So if that's 1 minute, you end up filling the tank with 50 liters every minute. And then 200 makes sense because that is your starting volume. So if you think about it at time t equals 0, when there's no filling going on, we said there's 200 liters in the tank. So at time t equals 0 here, when that's 0, your volume is 200. Okay, and how many minutes would a tank be full? So a full tank is 1,000 liters, but remember we started with 200 liters already in the tank, so we need to fill it with 800 liters more. So we set up the equation as 800 equals 50t plus 200. That is, let's bring it over here, that's 600 equals 50t, and t equals 12 minutes. So in 12 minutes, the tank will be full. What is the volume of water in the tank after 12 minutes? Well, we know it's going to be 800, but let's do the equation anyway. So volume equals 50 times 12 plus 200. 50 times 12 is 600 plus 200, and that in fact equals 800 liters. Sorry, so what is the volume of the water in the tank after 12 minutes? Yeah, that's right. So the volume is 800 liters. Okay? Alright, coordinates, quadrants, and intercepts. Plot the following coordinates on the grid and state the quadrant they're in. Point A is at 4, 4, so that's point A, and that's in quadrant 1. Point B is negative 2, 2, and that's quadrant 2. Point C is negative 1, negative 4, negative 1, negative 4. There's point C, and that is quadrant 3. Point D is at 3, negative 2, and that is in quadrant 4. X and Y intercepts, looking at graphs. Graph number 1. Graph number 1. What is the x-intercept? The x-intercept here, you can see the line passes through the origin. So the x-intercept is 0. And it passes through the origin, so the y-intercept is also 0. Graph number 2. There it is. The x-intercept, you can see it crosses through the point 2. Y-intercept, it crosses through negative 4. Graph number 3. This is a vertical line, and the x-intercept here is 3, and a vertical line never touches the y-axis, so there's no y-intercept, so DNE or does not exist. Graph number 4 is a horizontal line which never touches the x-axis, so does not exist for x-intercept. For the y-intercept, there it is, 1, 2, 3, 4. Okay? Moving on. Slope characteristics and finding slopes from a graph. In which graph does the slope of line L equal 0? Well, when M equals 0, we know that it is a horizontal line. So let's look for horizontal line. Not lime. Line. There you go. Horizontal line. Not that one. Not that one. That's a vertical line. There we go. There's our horizontal line right there. So your answer is D. In which graph is the slope of line L negative? So a negative slope going from left to right slopes downward, kind of like negative stock market performance, right? Your prices are going down. Okay, so let's look for a slope that is going down, going from left to right. This is going up left to right, so it's not this one. B, we have a slope that's going down when we go from left to right, so your slope, your negative slope is letter B. Let's just look at the rest of them. Letter C, that's a horizontal line, so that is not a negative slope, and this one is a vertical line, and that is not a negative slope. Okay, Next one, which line has a slope of -1/2? So remember, -1/2 is a rise of -1 over a run of 2. Okay, so let's see which one that is. This one, it rises 1 and runs 2, so this is +1/2, so it's not that one. This one, let's start from the origin here. It rises 2 and runs 1, so the slope is 2 over 1, or 2. It's not this one. This one, it rises 1 and runs -2, so 1 over -2. Or the other way you can think about it is, if you start at this point, it rises, let's go down, it rises -1, goes down -1, and runs over 2. So there's your -1/2 right there. Let's just finish off with this one. This one rises 2 and runs -1. So that's -2 over 1. So it's not this one. Okay, so it's letter C. The accompanying figure shows the graph of the equation x equals 5. So on to this one. What is the slope of the line x equals 5? So this is a vertical line. This is a special case, but let's just look at it in terms of rise over run. The rise is infinite. It just keeps rising and rising. It's a vertical line, but there is no run. So the run is 0. So anything divided by 0, we call that an undefined slope. Okay, so a vertical line. So this is a vertical line, and the slope is undefined. This one over here, let's do this one. What is the slope of line L? So let's start over here, and let's end over here. Let's count our rise over run. So rise, 1, 2, 3, 4 in the positive direction. So that's 4 over the run, 1, 2, 3 in the positive direction. So your slope is 4/3. On to this one here in the diagram showing what is the slope of line AB. So let's start here and let's end here. Again, let's count our rise over run. What do we get? 1, 2, 3, 4, 5, 6. 1, 2, 3. And let's reduce the lowest terms, and our slope is 2. Draw the line that passes the given point with a given slope. Label each line with its letter. Okay. Passing through, let's do letter A. Passing through -7, -2 with a slope of 5/4. -7, -2, 1, 2, 3, 4, 5, 6, -7, -2, there it is. And we set a slope of 5/4, so a rise of 5, 1, 2, 3, 4, 5, and a run of 4, 1, 2, 3, 4. Let's do one more, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay. Next one, letter B. Passing through -5, 6. So -5, 1, 2, 3, 4, 5, 6. With a slope of -2. So this is -2. We can think of it as -2 over 1. A rise of -2, so that's going down, and a run of 1. 1, 2, and a run of 1. 1, 2, and a run of 1. 1, 2, and a run of 1. So there's our line right there. Passing through 5, 4 with a slope of 0. So passing through 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Right there. There's 5, 4. And with a slope of 0. So that's a horizontal line. So that's all we need to do right there. Okay. So that's line C. Sorry, I should label this. This is line B. And the green one is line A. Okay, last one. passing through 3, -2 with undefined slope. So 1, 2, 3, -2 with an undefined slope. That should cue you into being a vertical line. So there we go, folks, and that is your line D. Range of falling slopes from flattest to steepest. So we don't care about negative signs here. We're just looking at how flat or steep the slope is based on what it looks like. Okay, so when we do that, we just look at the number. So I'm just going to say 1/2, 5, 3/4, 1, 0, 3/2, and 2. Let's just get rid of the negative sign so it's not confusing. So what's the flattest? 0 is definitely the flattest. That's a horizontal line. Okay. So 0. So that's done. What's the next smallest slope? So we're going from smallest to biggest slope. So what's the next smallest? That would be, let's look at the fractions. That looks like 1/2. So that's done. Next one would be 3/4. So that's done. Next one would be not 3/2, but 1, right? 1 is less than 3/2, so 1. Then 3/2. Then 2. And then 5. So these are your slopes from flattest to steepest. Okay, slope formula. Consider the line segment AB on the graph. Coordinates of A, that's V2. And coordinates of B is 8, 6. Let's recall the equation for the slope of a line. It's rise over run, or the change in y over the change in x. So from A to B, so going from point A to point B, what is the rise, or what is the change in y coordinates? So let's go here. So if we're drawing a dotted line, 1, 2, 3, 4. So that's a +4. We're going in the positive y direction. What is the run? The run is the change in x coordinates. 1, 2, 3, 4, 5. So your slope here is m equals 4 over 5. More practice. What is the slope of the line that passes through the points 5, 3, and -4, 1? Let's just write this up here so we don't forget. Slope equals y2 minus y1 over x2 minus x1. If it helps, label your numbers here. That's x1, y1, x2, y2. Oops. y2. So here, m equals y2 minus y1. That is 1 minus 3. Over x2 minus x1, -4 minus 5. Okay, that's -2 over -9. The two negatives cancel out, so your slope is 2/9. If the points 3, 2, and x, -5 lie on a line whose slope is -7/2, then x equals, so we know the equation for slope is right here. So we're setting up an equation to solve this. So we said the slope is -7/2, so -7/2 equals, let's label this again, x1, y1, x2, y2. So -7/2, which is m, the slope, equals -5 minus 2, y2 minus y1, divided by x2 minus x1, that's x minus 3. Okay, here let's cross multiply to simplify this, so that's -7 times x minus 3 equals So let's back up here. Let me simplify that top part first. So that's negative 7 halves equals negative 5 minus 2 is negative 7 over x minus 3. Now let's do the cross multiplying to simplify this. So that's negative 7 times x minus 3 equals, negative 14. That's negative 7x plus 21 equals negative 14. Isolating x, so we're dividing by negative 7, so that's x equals 5. So this x2 value is 5, so that's letter A. The line that passes through 1, 3, and 2y has a slope of 2. What is the value of y? Same sort of deal here. Let's set this up. That is the slope of 2, and let's say this is x1, y1, x2, y2, so 2 equals y minus 3, that's y2 minus y1, over x2 minus x1, which is 2 minus 1. So let's simplify a little bit. 2 equals y minus 3 over 1. So that is just 2 equals y minus 3. Let's add 3 to both sides, so that's y equals 5. So your y value is 5. So 1, 3, and 2, 5. Prove that the following set of points is collinear. So collinear means the 3 points all lie on the same line. So let me not draw a horizontal line. Collinear means that the 3 points all fall on the same line. So if we imagine this being A, B, and C, we see right away that if 3 points are collinear, then the slopes are equal. Okay? The slopes of both parts are equal. Okay? Let's calculate the slope of AB, and that is 0 minus negative 1, 0 minus negative 1, over negative 1 minus negative 3, negative 1 minus negative 3. The top part here, numerator is 1, over negative 1 plus 3 is 2. So the slope of AB is 1/2. So let's look at the slope of BC. That is 1 minus 0 over 1 minus negative 1. And that is 1 over 1 plus 1. That's 2. So slope of BC is 1/2. So we can say that slope of AB equals the slope of BC. Therefore, collinear.